Live from the Orion Cygnus arm of the Milky Way galaxy, this is Scientifically Speaking, a weekly half-hour program devoted to elegant curiosities, and I am one of your hosts, Sarah Chang, and joining me as always is Bernie Ryan, DJ Star Watcher. How are you, Bernie?
Yes, hi Sarah, very good, thank you.
Bernie's our professor of the astronomy lab at USM and our local protector of the night skies. Reach out to us at WMPG Scientifically Speaking at gmail.com or on Twitter at WMPG SciSpeak. And you can head over to WMPG.org to find the last 5 weeks of archives of all of your favorite shows, including this one. Bernie, could you let our listeners know what is up in the night sky for this coming week?
Yes, okay, I will, thank you. So this will be Friday, September 10th. So we're going to have a waxing crescent moon, which is the best phase. It's very picturesque. You see the little crescent and the earth shine, and then it's going to set about 9 o'clock, so then you can see the rest of the sky. The sunrise is around 6 in the morning and sets around 7, so we're getting close to the 12-hour days, just a couple weeks till fall starts. So basically you'll see the planet Venus in the evening, maybe up to maybe like half an hour, 40 minutes after sunset, so you have to catch a good view of the west of that. And then the main planets, still the best planets, are Saturn and Jupiter. They're past opposition, so they're already up pretty high when it gets dark, and you'll see them pretty much the whole night long. So we did have our annual Starfest, and both Sarah and myself were there, along with maybe 20 other people, fewer than I thought, but it was nice. The second night was nice and clear, so we saw the planets. I remember I got some of the best views of Saturn I've had since we had that view on Mount Cadillac with the Acadia Festival. Saturn through the 8-inch refractor was just amazing. You could see the shadow of the planet on the rings, and you could see several of the moons, of course. You could see the Cassini division. So really great image of Saturn. Of course, nice images of Jupiter. We had transits of the moons going on. You could see more than 2 cloud belts. You could see 4 or 5 of the bands around Jupiter. Then we looked at a few other objects too. So it was really interesting. And I even got to download a phone app where you can use a cell phone, and this is for all of our listeners. You can make a cell phone have a 10-second exposure and get really nice long-term exposures of the night sky. And one person there, Peter Gillette, was doing that, and it was
nice.
Really great results. So that's what we did that a couple of days ago.
Wow, I'll have to check out these new apps because I have tried doing that on my phone before, maybe like 2 or 3 years ago.
Mm-hmm.
It just didn't work very well.
Yeah.
The long exposure, I mean.
Yeah, it worked for him. So he was doing it, and he even did, us with the red lights moving around and the sky above
Very
us.
nice.
The Milky Way didn't turn out really nice, but the sky was pretty good.
Yeah.
Not perfect, but it's just a cell phone.
Nice.
Yeah.
Well, thank you, Bernie.
Yeah, you're welcome.
And if you couldn't take notes fast enough, you can also check out the monthly What's Up column in the Portland Press Herald. So, according to the Institute of International Education, around 5.5% of all U.S. enrolled students are international students. That actually equals to roughly 1 million international students each year. And for international scholars, these actually account for 123,000 or so, 124,000 people as of 2019-2020 academic year. And that's defined as scholars on non-immigrant visas that are engaged in kind of temporary academic activities. Actually, over 77% of them are engaged in STEM fields. And that's broken down into physical, life sciences, engineering, health professions, math, computer science, agriculture, etc. Most scholars come from, can you guess what 2 countries?
Asian countries, probably.
Do you know which 2?
I don't know.
Just by sheer size of the country
China
and the
Japan?
population. China and India, actually. So
India,
China, right. China is almost 35%. India is 10%.
Mm-hmm.
And so, with some of the recent things going on in the news and in the world, especially with Afghanistan and, this rise of xenophobia and just commentary from the populace, we thought it would be really timely to do a show specifically on kind of immigrant scientists, or basically scientists who come either here or maybe to some of the other countries that we're familiar with. Like I have somebody from Canada for various reasons. Bernie, You have somebody actually from one of our top two countries, from
Yes, I do.
India.
Okay, so she's not completely unknown, but her name is Dr. Sahini Ghose, Ghose, and she actually, I first saw a TED talk she gave quite a while ago, and then I did a lot more research into her and so on. She wanted to be an astronaut when she was a little girl, and now she has all the physics degrees and everything. But she has actually given four different TED talks and has written a book, or several books actually. So there was one on breaking barriers with quantum physics, another one how quantum physics can help us fight climate change. That's kind of interesting. We talked about climate change for a couple of shows. And then the surprising power of quantum uncertainty. So basically, she what she did. I mean, she also runs different institutes and so on. And she gave an interesting talk about like Alice in Quantum Wonderland. So kind of yeah. So if people had quantum powers, like what it would be like in the quantum world. So then, and then of course, basically, this is what particles do in the quantum world. But she kind of made it like personal and different powers and like related to people. So it's things like shape shifting, quantum tunnelement, quantum entanglement, and invisibility. So this is
Oh,
things that happens all the time at the quantum world. But she made it really interesting by placing it up to where people, and she has a good way of explaining all this. So she got into those things there. And then also, of course, the whole thing about the quantum algorithms for the computers and how that's involved in the cybersecurity. We had Dr. Laurie Sussman on
mm-hmm.
about cybersecurity, so it relates into that. And yeah, so that's basically what she was talking about. Mhm.
Awesome. And how did you find out about her?
Well, as I said, I watched a TED Talk with her maybe just about a year ago, and then I found out she actually wrote four TED Talks and several books. So, so I would just watch some more of that and how it applies to the latest thing on quantum computing. And actually, she did the first picture ever of an atom and how it would tunnel through a barrier. So she somehow was able to take a picture of it and showed it in her talk. And of course, it's not a set thing. It was red where it's more likely it was going to be at the time, and then it was blue where it was less likely, and then she showed where the barrier was and how it just tunneled through and back and forth. So actually, and we can't even see an atom in an electron microscope, but you can see it the way she did it with the lasers. Her whole PhD was interacting, atoms interacting with lasers and magnetic fields and how they're controlled. So this way you can really get a picture of what the atom and how quantum tunneling works and so on. So it's pretty amazing stuff.
Very cool. And her name was
Sahini
Sahini
Ghose.
Ghosh.
Yeah, Ghose.
Awesome. Thanks
Yeah.
for sharing.
Oh,
Sounds,
you're welcome.
yeah,
Yeah.
very accomplished actually.
Yeah. Hopefully, some of our listeners might look up some of her TED Talks, or these are some of the cutting edge topics now and things going on in that field. Quantum computers, I mean, obviously, they could help fight climate change just from, the power of those computers once they can use them for that.
Right, right. Very nice.
Mhm.
So in 2011, there began the currently ongoing Syrian civil war as part of the wider kind of 2011 Arab Spring protests. And that was out of discontent with the Syrian government, which quickly escalated into the armed conflict that we know of as today. And so there was a Syrian scholar who, in the midst of the Syrian civil war, spoke out in support of the student movement for their dignity, their freedom of speech, justice, equity for Syrian people. And she was threatened by the government for speaking out and, kind of suggested that she consider that a warning lest she be arrested for supporting basically peaceful protest and revolution. Um, and so Dr. Amal Alashkar, she started the first neuroscience research lab in Syria. And she was a graduate of the Aleppo University School of Pharmacy and also received her PhD from the University of Manchester in neuroscience. And so she had later kind of returned to Syria, where she was then the associate dean for student affairs and was also the associate professor at her alma mater. And at the time, it was really timely. She had received the Hubert H. Humphrey Fellowship, sponsored by the U.S. Department of State. And that brought her to Penn State, where she stayed for about 10 months. But then, the Civil War kind of continued. And so, for her safety, she basically couldn't return to Syria. And she later got another fellowship, which brought her to University of California, Irvine. And basically, as a scholar in exile, there's a lot of kind of uncertainty about being displaced and having to transition and understand the need to kind of really reestablish one's research career, completely restarting in a new place and a new country. So it's different from just going somewhere for a little bit and then kind of that slow gradual realization that you probably have to stay there for much longer than you intended and maybe even want to sometimes. So at the University of California, Irvine, Dr. Alashkar actually established the first online masters of pharmacology and, basically targeting people working in industry full time who have families, but, want to advance their education. And so right now, or while during her first kind of years there, her research focused on understanding behavior in health and disease. And one project was focused on the impacts of stress during pregnancy of the children born to people who have been displaced for one reason or another. And so, a famous example is the Dutch famine during World War II, where there was increasing rates of mental illness in the offspring of mothers who were pregnant during the famine when the Nazis had invaded the Netherlands. And so this is also seen in the Tutsi genocide in Rwanda, or one of the effects of that, where offspring of mothers who witnessed the genocide, either family members who had died, were found to have higher rates of depression and PTSD, or at least their children were. I'm sure they also did. And so Dr. Alashkar's research works to essentially understand the early stage mechanisms that happen in the brain that may have long term impacts and ultimately to help find a treatment or better preventative therapy. As a neuroscientist, she can focuses on psychiatric disorders such as autism, Parkinson's disease, depression, schizophrenia, and generally tries to understand behavior in those states and how the brain circuits, regions of the brain are connected to control specific behaviors, memories, emotions, and just generally understand, when things go wrong in the brain and, why. And so some of the things that her research has brought her to consider, and she hasn't made kind of any groundbreaking conclusions, but it has made her question whether, for example, schizophrenia, autism, or Alzheimer's could be the same disease. And so a lot of her work right now is in the lab looking at cell differentiation in rats. What are the types of chemicals that are released? What are the cell interactions, the metabolic pathways, etc. And I really like one of the quotes that she often says to her students, which is, "There's no concrete answer or absolute truth. You have to find the truth. You have to search for the truth. And the knowledge that I am teaching you is what we have now. This knowledge might change in the future, and you're part of the change of our knowledge."
Mm.
I thought that was just very profound because,
Mm.
I'm sure some of the stuff that we've said even, you know, 2 months ago
Yeah, and a lot of
is,
things in
is now
astronomy. I mean,
changed.
just look at a few years ago, they were wrong.
Yeah, yeah.
Yeah, yeah.
So look her up, Dr. Amal Alashkar. That's
Mhm.
Alachkar. And Bernie, you have somebody all the way from Germany.
Yes, right. So not as far away and not one of the top two countries there, but so a little more local. So her name is Dr. Catherine Fries. She's probably not as famous as Sahini Ghose, but she had given some TED Talks and she also wrote a book. So maybe our listeners could look up some of the things that she's done. So her degree is in astrophysics. So her field is the cosmology and studying dark matter, basically, and how cosmology interacts with particle physics and ways to communicate it. So, of course, we pretty much all know that about only 5% of the universe is visible. So, about 75% of it is dark energy and 25% of it is dark matter. So, her field was to get into the dark matter, of course, with all the math and physics behind it. But she has some interesting theories which may be proven to be correct. And we may actually have some proof of this when the James Webb Space Telescope goes up, hopefully by the end of this year. And once it gets calibrated, so we may know some of these answers by early next year even. So basically what she is saying is that there's something that could make up dark matter, which is called dark stars. So
Mm.
these are stars at the very edge of the universe, like a redshift of 10 to 50. I mean, that's way out there. That's like just about at the edge. Far away, like a redshift of 2 means halfway to the edge. So every time you have another number, it goes another halfway. So a
Hmm.
redshift of 7 or 8 or even 10 is pretty far, but when you get up to 50, you're just about at the edge. So these are stars that don't have very much dark matter in them, just a tiny bit of it, like 1,000th of their mass. But that's how they basically fuse. The star is all hydrogen and a little bit of dark matter, and that provides the fusion for that star. So they're so far out, and of course they don't exist anymore, but we can see to the edge of the universe. So she hadn't actually found them, but she modeled them with the computer programs and everything. And so basically that could then show us new types of fundamental particles like axions that might be making up this dark matter. So basically she just has different theories and really interesting ways to do this. She won some prizes. They weren't Nobel prizes, but there
Mm.
were some other prizes for communicating these new ideas. Actually, she did mention that the father of dark matter is Dr. Fritz Zwicky, which he came up with this. This has
It's
been
always a
around
great
for,
name.
it's a great name. I know there's someone in our club named Ian Durham that loves that name. So this came up way back in the 1930s. And then, of course, Vera Rubin found the way the galaxy is rotating, there has to be a lot more material that keeps all the stars pretty much going at the same speed. And that was like in the 1970s. So it's been around for quite a while. So it's it's time for some of the new theories like that she's come up with. She came to this. She was born in 1957 and
Mm.
came to this country when she was 9 years old. And she has degrees from Princeton and Columbia and University of Chicago and all that. But she did give some really interesting TED Talks. She wrote a book called Cosmic Cocktail, Three Parts Dark Matter.
Love it.
So yeah, and there was an image of that in the background for her TED Talk and so on. So it's just like one of the different prongs for the hunt for dark matter. Now I did have a neighbor where I used to live on the lake in West Newfield who had it one of the dozen or so top experiments under the ground, like a mile down, to look for particles that could be making up dark matter. So they haven't found anything yet. He also taught at Brandeis and he worked at CERN. So hopefully, of course, that might find something, or Dr. Catherine Fries might find something, and so on. But it's interesting that some of that might be proven by the time we get the James Webb Space Telescope up there.
Nice.
To see if there's something like dark stars up there, or even what dark matter is in general. But dark stars could be a big component of it.
Yeah, yeah.
Mhm.
How did you find out about Catherine?
I think actually I was looking specifically because I hadn't really heard of her before, but at least she's well known enough to have given some TED Talks. And then I watched some of those. I had heard at Sahini Ghose before, but not yet. And then she was from Germany because I mean I'm from Germany too originally. I was born here, but some German in the background. Of course, there's lots of other famous people from there, like Einstein and a lot of people. And but we wanted to do live people that are still here and contributing, not famous immigrants that aren't around anymore.
Right.
Yeah.
You like talking about Einstein a lot.
Well, yeah, I mean, I looked up other immigrants, and of course Max Planck and
Yeah.
Wernher von Braun, who started NASA with the rocket science and all those things, type of things. But yeah, so we wanted to do current people.
Yeah, yeah.
Yeah,
Awesome.
yeah,
Catherine Fries.
yep,
So we'll be able to find out what was that? Cosmic cocktails?
yeah. That's her. That's one of the. She may have written several books, but that's the one she had on in the background of her TED
Yeah.
Talk. Yeah,
Love it.
yeah,
Wow, there's been a lot of contributions
yeah.
by some of these folks.
Oh, as you
It's
said, like half the people are pretty much. Oh, one year in 2016, all the Nobel Prizes in science were actually given to immigrants,
mm,
and often
yeah,
it's about half.
yeah,
Half the
yeah,
scientists and engineers are pretty much immigrants studying STEM fields and that physics and astronomy. Half of them are
right.
immigrants even now. So,
Yeah. I mean, I think it speaks a lot to,
mhm,
we hear the trope of, oh, like immigrants are coming to take our jobs, but
mm,
these are people who are coming and contributing
yeah,
to the wealth of knowledge and their publishing and,
right.
keeping kind of the US as I think we probably been surpassed by China in terms of papers published in journals,
Oh.
but I don't quote me on that. That was just
Mhm.
possibly something that I
Yeah.
had skimmed over.
Hmm.
But these are people who come here to participate in our higher education system and to contribute to the research and development of really cool things.
Hmm.
So, anyways, next person that I wanted to highlight, and I think I wanted to highlight her just because her research was so interesting, but she also happens to hail from Syria. Um,
You
so,
said the word
okay.
Syria.
So, Bernie, do you, as somebody with a background in organic farming, do you
Mhm.
know what a pulse is?
I've heard of it, yes, but I forgot right now what it is.
So okay, I don't know if I've actually heard of this term, but
Mhm.
the first evidence of a pulse was actually found in the Fertile Crescent, which is the region where Syria now sits. And a pulse is actually just a crop harvested as a dry grain. And so that's different from crops harvested while green or, young or whatever. And so they're essentially the edible seeds of plants in the legume family. So dry beans, dry peas, chickpeas, lentils, etc. So, Dr. Rana Mustafa studies pulses and their functional properties being used to replace meats and animal proteins.
Hmm.
So, when you cook a pulse, it results in the cooked food and then the water, which is called aquafaba. And if
Hmm.
what was that one guy's name that you said Ian Durham really likes his last name? The
Fritz Wiki.
Yeah.
Yeah.
So Fritz Wiki, we'll learn that word today or name today. And then
Mhm.
fun word for today, aquafaba. That's
Mhm.
aqua FABA. And so this aquafaba, again, it's that water kind of where, after you cooked your beans, this contains chemical properties that can be used for thickening, emulsifying, or foaming. So I don't know if you've ever noticed when you cook it, it is kind of thick and it is like if you kind of whisk it up, it's foamy. And so the latter two of those properties, the emulsification and the foaming, they actually mimic the properties of eggs and milk protein.
Hmm.
And so Dr. Mustafa studies the chemical composition and the rheological properties, which is the property of a substance's viscosity, to see how the foaming capacity and stability of chickpea aquafaba might vary with different additives. And so basically, what she's found is that aquafaba with no salt or EDTA, which is a common preservative in canned foods, are more viscous and have more stable foams than those with the additives. And so she had actually done a study where they basically took different brands of canned chickpeas and tried to replace eggs with that aquafaba. And what she found is that, and then they baked basically a bunch of sponge cakes. And so the sponge cakes baked with the aquafaba were kind of less springy and a little bit less cohesive, but the conclusion was that it has the potential to replace egg whites in eggless cake recipes. And so much like your first person, Dr.
Took me go.
Ghosh,
Yeah.
yes, Dr. Mustafa, basically, this work kind of contributes to this. I don't know if it's this revolution, but we see a lot more plant-based foods on the market nowadays.
Mhm.
And our last show where we talked about methane, a good third, more than a third of methane emissions actually come from grazing animals. Most of that is cows. And so, this is all, it kind of supports this whole, um, it's a strategy to help curb some of the climate change and specifically, emissions of methane. And by helping to make these kinds of foods more appealing, this is kind of a proposal of a low cost alternative to develop gluten free and vegan and plant based milk and baked goods, beverages, and other types of products. And so she likes to say that it helps people kind of become more flexitarian, to moderate their meat consumption and enjoy freedom in the foods that they want to eat. So she is actually was a visiting professor at the University of Saskatchewan College of Agriculture and Bioresources. And then she worked as a food scientist with Prairie Tide, which they developed gluten free and vegan products from pulses and flaxseed as well. And I believe now she is a food scientist with the Global Institute of Food Security. And so they focus very specifically on finding solutions to challenges facing the global food system. Anyways, really cool stuff. And um, she got a PhD in food biotechnology and processing from in France, and she actually lived in Homs, which is one of the larger cities in Syria, and very similar to Dr. Alashkar. She couldn't stay anymore because of the civil war. Bernie, you've take us to space with this next person.
Yeah, yeah, I have one more. I just saw a tweet by him. I'd never heard of him. He didn't write any books. He didn't give any TED Talks, but he might be famous one day. So he's from Japan. His name is Hiro Ono. He's 38 years old. And what I like is that he was saying like how dreams can come true when he came to this country. What inspired him was kind of interesting. In 1989, and I remember watching this, there was this program about the Voyager 2 missions, Neptune All Night from JPL Live out in California where
Yeah.
he works now. He was only 6 years old at the time. So that inspired him. And actually, Neptune's interesting because for our viewers, I mean, you need a telescope to see it, but it's at opposition on September 14th. We didn't see it the other night, but you can see it in a telescope. So it's kind of neat little connection how that inspired him. I don't know if he may have also wanted to be an astronaut. So he ended up working for NASA, and he's an engineer there, and he worked on the Perseverance rover. So when he wrote this tweet, the rover hadn't been launched yet. It was launched last July when Mars was close to us. But he worked on the algorithms to actually have the rover do some of its work. So of course, he wasn't the only one working on that, and I don't think he has a PhD, at least not at this point. But then he gave some views of his grandparents in Japan and how they inspired him, some of the things they did, the different views back in World War II, how we were cutting down the Japanese, and they were calling Americans and Britons devils and beasts. I mean, this all the negative propaganda and so on. We were interning Japanese Americans after World War II. Actually, his parents were interned, and here he's a brilliant scientist working on the Mars rover. So just how some of the attitudes have changed. And then he wrote a few things about how the dreams can come true here. And he did also write about Senator Dan Inoue. He was one of the people that fought Japanese American soldiers, and they won Purple Hearts and so on. So just the whole view of how that can work and help people. And then he was also writing about potentially other people, like people from Syria, that could then be working at NASA and developing some of these programs. So he had really high hopes for the future also, but how immigrants can work together at NASA and other places, not just NASA, of course.
Awesome.
Yeah,
So Hiro Ono, right?
yeah, 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 like Yoko Ono.
Yeah. Awesome.
Yeah.
Well, I think that actually wraps up our scientists for our show today. And hopefully you learned something new and learned about some folks that maybe you wouldn't have heard of before, but some really cool people who are making pretty amazing contributions. You've been listening to Scientifically Speaking here on WMPG with myself and Bernie. Stay tuned for Disco Jams with Jam Lewis from 1:30 to 3 today. And from your favorite nerds, just a reminder to vaccinate, help mitigate, and we can all congregate.